Okay, I'll try not to blast everybody with the microphones. Good morning. We are going to thank you. Oh, let's try that again. It's Monday. Good morning. Yes, I love that. That's wonderful. And it's quiet. It's amazing. It works in Sunday school. It works here too. So thank you for coming to the fourth and final part of our marijuana news series. As I've said from the beginning, I see this as the beginning of a conversation that's going to continue as we move forward from here. A couple of housekeeping notes. If you participated in a previous session and you never picked up your certificates, I have them over there on the table with some of the other previous handouts from different sessions. All of these sessions are available. We've sent them out through our weekly update, the email the AOD Partnership sends out. So if you are looking for any of these handouts electronically, you can definitely let me know. This is a plug for the AOD Partnership's weekly update. Our e-newsletter has drug trends, trainings, meetings, opportunities, and pretty much everything you see in the news. It's our way to keep you in the know. You can sign up online. It's right on those swanky pens that were out front. Feel free to get your smartphones or your tablets out now and sign up, because that's how all the handouts are going to go out electronically after today's event. Also, we're going to be recording today, so we can be able to use this for future use. We're unsure exactly the platform on what that's going to look like, but again, that's going to go out through our weekly update for you to access it. So another important reason why people should sign up for that. And if you don't like it, just click on subscribe. But I think it's pretty fantastic because I'm humble like that. I'm Melissa Moore. I do the substance abuse prevention work here at the Health Department of Marathon County. Much of my time is spent with the AOD Partnership, our local substance abuse initiative. It is a local nonprofit whose mission is to lead prevention, education, and awareness efforts to reduce substance use. So we are really fortunate to be partnering with Ascension St. Clair's for this series. They invested a significant amount of funds for us to be able to bring in wonderful national level speakers like Dr. Harris that we have here today. So I want to give a shout out to them, as well as NTC, Continuing Ed, for the great work that they do to help support us here. If you are looking for CEUs for this session, we did not print out actual certificates, but you should check in with the registration. They'll check a box and they'll get you a copy of your certificate right in your email box. So that is something I needed to make sure I updated on. The recording, restrooms out the door. You can go through the kitchen, they're straight ahead, or kind of work around the registration table. There'll be coffee and breakfast out there all morning, so make sure you can help yourself. We'll take a break when there's a natural break, figure in about an hour and a half or so, but if you need to get up, please do so. Silence your cell phones if you could, and the presentation will go out again through email, so just know that you will get the slides eventually. With that, I'm going to turn over to Dr. Sion Harris. Thank you again for coming, and a big round of applause here.
Great. Thanks, everyone. Thank you so much. It is my pleasure to be in beautiful Wausau for the very first time. I was driving here with no traffic. I was like, this is really, really nice. And your skyline is not yet sullied by big billboards selling marijuana, which we have in Massachusetts. So thank you so much for coming this morning. So I'm going to be focusing on marijuana today. And what I want to do with the time that I have is to update you on the latest science, what we see in the research literature about how marijuana affects the teen brain and other aspects of their health. Some of it you may have already heard, some of it maybe not. I might go into a bit more depth than what you might typically get. And I definitely want to encourage you to raise your hand and ask questions if there's anything that's unclear, okay? All right, so let's clear away the smoke. So I just wanted to quickly introduce myself in terms of, so I direct the Center for Adolescent Substance Use and Addiction Research at Boston Children's Hospital. I'm also an associate professor of pediatrics at Harvard Medical School. My background is public health. I'm an epidemiologist and behavioral scientist. And I've been doing research in adolescent substance use, screening, prevention, intervention, treatment for about 20 years. And during that time, we've made a lot of progress. And there are things where we've kind of gone backwards, and so we're kind of pulling out our hair from like having lost progress. So anyway, we'll talk about that shortly. All right. So I wanted to just first set the stage here, give you the context of where we are with marijuana policy in this country. I call this the other greening of America. So you can see that, so there are different shades of green here. We've got the dark green, which have fully legalized adult use, that is recreational use of marijuana. We also have then those that have, full comprehensive medicinal marijuana use legalization, and then a number of states where like Wisconsin, where only the sort of low THC, high CBD products are legal. So anyway, this is now, as you can see, only 4 states don't have any kind of marijuana policy. So we have 34 states that have legalized medical marijuana. This includes those that have also legalized adult use. And then 10 so far that have legalized the adult recreational use, 12, with Wisconsin being one of them, that have legalized the low THC, high CBD, that is the hemp based products. And then, of course, we still have Schedule 1 designation of marijuana, meaning there's no beneficial use of marijuana, and it's highly addictive. That's the Schedule 1 designation at the federal level. So we are in this very kind of schizophrenic place. Okay, so now, but this is a rapidly shifting environment. This news story just I found yesterday. This is the Chicago Tribune. So Illinois, your neighbor, is looking at legalizing marijuana adult use, which would allow possession of up to 30 grams or 5 plants at home. So these things are rapidly changing. Now, here are some images about marijuana that young people see today, associating marijuana with medicine. And as I said, those annoying billboards everywhere. This one says, if beer and golf make for the greatest party on grass, why can't adults enjoy a safer party on grass? So these are the kinds of things that young people are seeing today, particularly in those states where either medical marijuana or adult use marijuana is legalized. So, and then there's all the marketing. So once you get the commercial interests at play, then you have all the advertising. So these are just some of the advertisements that are on social media that capitalize on familiar kind of stars, popular figures. That's Michael Phelps, and then even Obama, President Obama. There's things like this here. It says, marijuana inspiring successful Americans since 1776. A lot of don't let the government fool you. So this is the kind of information that young people are bombarded with. So it's not surprising that what we are seeing is this declining perception of risk of harm of marijuana use. This is from national survey data of 12th graders. This is a National Monitoring the Future survey that's conducted every year. It's been being conducted since 1975 of a national sample of 8th, 10th, and 12th graders. So this is the percent that report that regular marijuana use is associated with a great risk of harm. So you can see here that we had this increasing perception of risk of harm through the 80s, interestingly, and then it's been on a pretty steady decline since then, and we are now at a historic low with only 27% about 1 in 4, thinking that regular use of marijuana is associated with a great risk of harm. Now, we know from a lot of science, actually, that perception of risk of harm is correlated with use. And this is, illustrates that. So this percentage in red is the percentage of 12th graders that report having used in the past month, having used marijuana. And you can see there's this mirror-like relationship between perception of risk of harm and use. And so we are at 22% reporting past 30-day use of marijuana nationally. Okay, now, so again, just continuing with giving you the context. So this is from the National Monitoring the Future Survey, the latest data. This is the percent of 12th graders reporting use of each substance in the past month. And so from 2000 to 2018. So you can see that there's this nice decline in past 30-day alcohol use, a tremendous decline in past 30-day tobacco use. Even the use of other drugs, other illicit drugs other than marijuana is going down. So the general trend of substance use among adolescents in this country is to be declining. But here's marijuana. So we had seen a similar kind of decline in the early 2000s. But then, around 2007, it started to go up. And then this amazing thing happened in 2009 where tobacco and marijuana use that they crossed. So now we have much more marijuana use versus tobacco use. And now, interestingly, in 2009 is when Colorado allowed a commercial marijuana industry and really just exploded the advertising around marijuana. And that's when it happened, right here. Now, I just want to mention here, I don't have time to talk about vaping today, but that's the other, really concerning thing right now with adolescent substance use. So you can see in just a few years, we've had this steep incline in terms of the frequency or the percentage of adolescents reporting vaping in the past month. And this is vaping nicotine, and that's actually, just about at the level of marijuana use. Now, we're seeing this co-use, actually. More than 1 in 4 adolescent e-cigarette users are saying that they also vape marijuana. So because they have the device that can be used for both. So that's a trend that we're starting to see as well, is more of the use of both nicotine and THC oil, which is really concerning. Okay, and then in terms of heavy use, so these are the trends in heavy use. Again, 12th graders, this is really amazing. We've cut binge drinking in half over the last 20 years, almost 20 years. Binge drinking defined as 5 or more drinks in a row. We have cut daily cigarette smoking, at least of the combustible tobacco variety, by from 20% to 4%, which is incredible. We've even cut regular alcohol use, daily alcohol use, from 3 to 1%. And then here is daily marijuana use. And again, we had seen a little bit of a decline here, but then it's pretty much gone back up, and it's back to where we started back in 2000. I want to just highlight the difference here between daily alcohol use and daily marijuana use. So we have a lot more young people who are using marijuana daily compared to really anything else. So the implication here is that marijuana use seems to both, whether it's their perception of harm that's driving it or its addictive quality is driving many more young people using marijuana daily as opposed to anything else. Okay, so what? So you might have heard these various myths about marijuana, that it's not addictive, it's harmless and natural, it's safer than alcohol. How many of you have heard these being said by young people? Right? Okay. All right, let's take a look at the science. Okay. So let's look at the science around, is marijuana addictive? So there's a pretty straightforward way that scientists study the addictiveness of drugs. So they use animal models, so rats or monkeys, and they basically just allow animals to self-administer the substance as much as they want. And if they see that the animal, just goes back for more and more and more, that's a pretty good indication that that substance is addictive. And we now know that that there's a part of the brain in humans as well as animals. This is what we call a highly conserved part of the brain across mammals. That's called the reward pathway. It includes these areas that are highlighted in orange. And the reward pathway, which you've probably heard, is the part of the brain that's involved in giving us a sense of pleasure, as well as what drives our behavior in terms of wanting to do things over and over again that give us that pleasure. And we now, and that part of the brain was probably what helped our species survive by having us do the things that keep our species alive. So, and this particular part of the brain is called the striatum, and that's where those brain cells that are involved in dopamine, that chemical that is released when we feel pleasure or we take notice of something, that's the part of the brain that's involved. And as I said, that part of the brain is involved in giving us that natural reward when we do things that keep our species going. So eating. So this is actually from rats, where they were able to measure very precisely the percentage, the release of dopamine in that part of the brain, the striatum. So you could see the little bump when the rats were exposed to food, the big bump when they were exposed to partners. So these, so procreation. So these are the natural rewards that elevate dopamine levels in that part of the brain. And we now know that the reward pathway is activated by every single addictive drug as well as addictive behavior. All of these different kinds of substances that we know are highly addictive. And so, for example, here is the spurt of dopamine that happens with amphetamine. The scale of this is just tremendous. This is 10 times the amount of dopamine release that we get from food. So this is, so you can see why methamphetamine is so addictive, and why people don't need to eat if they get hooked on, amphetamines. Here is cocaine. Again, in that part, the reward pathway, this is the big release of dopamine, and why that cocaine is so addictive. And THC, the psychoactive chemical in marijuana that creates the high, is no exception in terms of increasing dopamine release in that part of the brain. So biologically, marijuana is absolutely doing the same thing that other addictive substances are doing in the brain. Now, marijuana, it turns out, is especially addictive for teens. So this is national data from the National Treatment Episode Data Set for substance abuse treatment admissions. And the percentage of those treatment admissions for ages 12 to 19 for teenagers that are related to each kind of substance as the primary substance of dependence when they enter treatment. So 13% are related to alcohol as the primary substance, 9% for heroin, 2% for cocaine, 7% for methamphetamine and other stimulants. Nobody would argue that those are highly addictive substances. Here's the percentage that are entering treatment because of marijuana as the primary substance of dependence. So among adolescents, marijuana accounts for more treatment admissions than all other substances combined. Yes? These are both. These are both, everything, yeah. From publicly supported treatment programs, yeah. So if marijuana wasn't addictive, why are so many young people needing to get treatment to address marijuana dependence? Now, you might hear, well, marijuana is natural, okay? So it's better than, other things that are like synthetic, I guess, I don't know. Well, other things that are natural, arsenic, asbestos, formaldehyde, hemlock, okay? Just because something is natural doesn't mean that it's safe. But somehow that narrative, has gotten out there. But let's just have some perspective here, okay? And one of the things that has been, actually a benefit of, increasingly legal marijuana is that there are rules around testing the product. And this article just came out in the Smithsonian.com that said modern marijuana is often laced with heavy metals and fungus. So it turns out that the marijuana plant can actually absorb heavy metals from the soil. And that can get passed, into the product that people buy and then take into their bodies. Here's a picture of a marijuana plant just covered in mold. And this is actually quite a problem in the industry. And it's hard for the testing facilities to really get out there and test in a timely way. But the testing facilities are saying that they're finding a lot of kind of these mold and fungus infestations in marijuana product. Okay, is marijuana harmless? Well, I would contend not for the teen brain, and you don't have to take my word for it. You can get it from the US Surgeon General. Science on marijuana says it isn't a harmless drug. Impact on younger brains is especially dangerous and addictive. Again, we're just kind of fighting upstream in terms of a lot of advertising that's saying that marijuana is harmless or that it's beneficial. But actually, it's important to also, have a more balanced perspective. So in terms of the teen brain, what we now know is that adolescence is a sensitive period in brain development and that the brain is still developing until about the mid-20s. And you've probably all heard this by now. But what I want to do is dig a little bit deeper to really characterize what that means. I want to highlight these two words, sensitive period, because they have a particular meaning in brain science. So sensitive period refers to windows in brain development when a part of the brain is developing rapidly and is highly sensitive to being shaped by environmental exposures and experiences. So when a part of the brain is going through that sensitive period, the development is actually very much being shaped by experience. And we now know that adolescence is the last major sensitive period in brain development. We know that, so brain development is an interaction. So what goes into brain development? So it's an interaction both of our genetics, what we come into the world with, and all those exposures through our lives during those sensitive periods. So for example, what family environment we are exposed to, what environmental exposures we are exposed to, and what chemicals our brains are exposed to during these developmental years. Okay, so I want to unpack for you a bit what we mean by brain development during the adolescent years. So I want to highlight two key brain development processes that are occurring until the mid-20s: pruning and myelination, okay? So to describe what those are, I got to highlight the friendly neuron. So this is the kind of major working cell of the brain. We have about 100 billion of these in our brains. And this is what neurons look like under an electron microscope. So we have the cell body, and then each neuron has all these long spindly arms or branches that reach out to connect to other neurons. So it's like a forest. So from birth, or actually before birth, until about ages 10 to 12, the brain undergoes something called blossoming, or rapid growth. And you can see it, when a baby is born, you've got a small head, and then as they grow, their head gets bigger and their brain gets bigger. So during that period, there's an increase in the number of neurons and increase in the number of connections between neurons. So just illustrating, you get this growing density of neurons and connections. However, around age 12, neurons start to undergo pruning based on the use it or lose it rule. So the use it or lose it rule basically means that the cells that are used, the cells and the connections that are used a lot, they get kept and strengthened. And the connections that are not used get pruned away. And this starts to happen around age 12. And this is why it gets much harder to learn a second or third or fourth or whatever, another language after the age of 12. Where, if you do learn another language, it's usually with an accent. But if you had started much earlier, usually you don't. Okay, so just to illustrate, so at birth, we don't have as many neurons, we have small brains, and then you get this rapid growth of brain cells, and then you start to see the kind of thinning out happening during the adolescent years. Now, at the same time, something called myelin starts to cover what we call the axons, or the arms, those branches coming off of the central cell body of the neuron. So myelin is a fatty white substance that acts like insulation on an electrical wire. So it helps to kind of keep that electrical signal, which is how the brain cells send signals and communicate. It helps those signals travel 100 times faster. So myelinated neurons are really important for speedy, efficient signaling across different parts of the brain. And let me just show you what those white matter tracks, or those axons that are now covered in the myelin sheaths, what they look like. So this is somebody's brain where we were able to strip away other parts of the brain just to really show you what we call the white matter tracks that connect the front of the brain with the back of the brain and the two hemispheres. And I call this the brain's information superhighway. So it allows communication to be really fast, across like relatively long distances in the brain. So the result of this pruning and myelination process are faster but fewer connections in the brain and a speedier, more efficient brain. So why does the brain do this? Just to show you, these are images of what we call now the brain's connectome. So these are the white matter tracks, those fibers that link neurons all over the brain. And we can now see this connectome, or the wiring of the brain, in greater detail than we have ever been able to see. And we are seeing in brain research more and more how important the brain's connectome is, that wiring up, to proper brain function. So what we're seeing are in psychiatric disorders, in neurological disorders like autism, even ADHD, that there are issues with the brain's connectivity, that is part of the problem in those disorders. So this connectome is really, really critical. So I just want to show you with this little video, actually a brain changing from sort of unmyelinated neurons that are gray to white matter, which are the myelinated neurons. So here's what happens from ages 5 all the way to 20. So just being able to see it in action is pretty incredible, and just enforces for me just how important the adolescent years are for that brain maturation and healthy brain maturation. Okay, so why does the brain do that? So it's like speeding up the commute. So this is my commute to work each day, and if I have a choice, I'm going to try and go from point A to point B as fast as I can, and not go ways that'll take me much longer. So that's what the brain is doing. It's trying to speed up the signaling across different parts of the brain. So it's kind of strengthening the highway system and kind of pruning away the local roads, which kind of slow down the communication. So that's really critical to our having a more efficient brain. And why is that important? So here's different functions, different parts of the brain that are involved in different functions. And you probably have all heard of the prefrontal cortex by now. We sometimes refer to it as the CEO of the brain. That's the part of the brain here right behind the eyes and the forehead. And that's that's really critical for our ability to act like adults, be able to organize ourselves towards goals and reaching them, planning well, being able to control impulses, being able to regulate our emotions, and having good judgment, being able to think rationally. Now, in order for that part of the brain actually to do its job, it needs to be connected up well so that with other parts of the brain that are doing other things. So for example, so that's the prefrontal cortex, and I call that the brakes of the brain, okay? Because it's often what's needed to kick in when we're in a heated moment, and we want to kind of have an outburst, but then we might regret it later. So our prefrontal cortex might kick in at that point and have us be able to kind of breathe through it or walk away or whatever. Now, this other part of the brain is not at all about that. This other part of the brain is involved in reward, emotion. I call that the gas pedal part of the brain. So that part of the brain is, what is activated when we're angry or sad or, super excited, as well as what is involved, as I said, in rewarded behavior that we know is what gets activated by substances. So in order for our prefrontal cortex to, really help us self-regulate and, control our impulses, it needs to get connected up well and, have signaling be very fast and efficient with this part of the brain, okay? And it helps us to go from this to being able to do this, where we're able to say, maybe this isn't such a good idea for me, and, inhibit that, like, impulse to go for the, high fat, high sugar, or whatever it is that is so rewarding for our brains. And so, but what I want to also do is actually go a little bit into detail about the gas pedal in adolescent brains. This study actually compared the activation of the reward pathway across age groups. So in an MRI scanner, child, teen, and adult participants in this brain imaging study played a game with rewards where they could earn small, medium, and large cash rewards, okay? So this was, getting something pretty useful, cash. They then looked at how that part of the brain, the reward pathway, got activated in response to their finding out what kind of reward they got. So this is the brain response to a small reward. The blue line is the brain activation in children ages 7 to 11. And as you can see, for children, that small reward still got them very excited. And this is why you can use like stickers as rewards for little kids, okay? Now here's in black, adolescents. So here's what happened. So they were anticipating getting a nice big reward. They find out that they had a small reward for this one. And their reward pathway actually deactivated, like they got unhappy. Like they said, this is lame, why am I doing this, okay? This is why adolescents are not that motivated by things like a clean room, okay? And then here's in green, the activation for adults, adult participants. Not a whole lot going on, it's just a small reward. It's like ho-hum. Okay, here's what happened with a large reward, okay? So again, children, they're also excited. Whoopee, whether it's small reward, large reward. But here's what adolescent brains did. Their brains activated even more strongly than any other group in response to a large reward. So the implication is that adolescent brains have a greater response to highly stimulating activities, which might be why they love doing stuff like this, and like that, and of course, substances that are highly stimulating. We know that the reward pathway is highly activating of that reward pathway. Now, you probably heard also that generally the brain tends to develop from back to front, so that parts of the brain in the back tend to get kind of mature faster than the front of the brain. So that whole pruning and myelination process, getting the front of the brain hooked up with the rest of the brain, that takes the longest time. And that's what goes well into the mid-20s. Now, so that means, so if you recall, this is the braking system, this is the gas pedal, that in the adolescent brain, the gas pedal is hypersensitive while the braking system is still developing. So they've got that, go for it part of the brain actually quite well developed, while the braking system is still in process of finishing maturing. So the key points on the developing adolescent brain, So we now know that teen brains have a stronger reward response to addictive substances. The gas pedal of the brain develops faster than the braking system during adolescence, and teen brains change faster because of that, what we call neuroplasticity, because it's going through a sensitive period of development. Teen brains change faster in response to using alcohol and drugs and can get addicted faster than if exposed to addictive substances later on when their brains are more set. So we know that 9 out of 10 people with addiction started using substances before they turned 18, which is why it is so important if we're going to make any headway around addiction that we gotta, address adolescence. And addiction happens because the brain changes. Addiction happens because the brain has gone through physical changes and chemical changes that wires it for addiction and causes a person to need to keep using the substance. And that's, adolescent brains are much more vulnerable to that kind of change. And sure enough, so this is national survey data that asked adults the age at which they had their first drink and asked adults a variety of questions to see if they had a problem with alcohol use. And this is the percentage that met criteria for an alcohol use disorder. And as you can see, the earlier they said they started using, the higher the percentage that met that criteria for having alcohol addiction. So, there was a 5-fold difference in risk if they started when they were 13, 14 compared to if they waited to start, at the age of 21 or older. And this is the same pattern that we see with every single addictive substance. So you could, this is marijuana, nicotine, anything. Same pattern. So the teen brain is what we call highly neuroplastic. It's highly malleable. And it's a double-edged sword. So I say it's both a time of opportunity and a vulnerability. So because the adolescent brain is able to change more quickly in response to experience and practice, adolescence is a great time to learn something or to get good at something through practice. So whether it's learning an instrument, working on a sport that you love, whatever it is that, teens would like to be doing and get good at, this is the time to do it. It's much harder. It takes longer to learn something and get good at it after the brain has gotten more, set, after that sensitive period closes. But of course, the teen brain is also more vulnerable to being harmed by alcohol and drugs compared to the adult brain. Okay, now I want to focus on the teen brain on marijuana specifically. Are there any questions before I move on about sort of generally teen brain development? Okay, great. All right, let's focus on marijuana specifically. So what is in marijuana? In order to know how marijuana affects the brain, we gotta know, what are the chemicals, components of marijuana that might have that effect. So, you've probably heard marijuana contains many different chemicals, and many of them are called cannabinoid chemicals, but there are other kinds of chemicals like terpenes. But I want to focus really on THC, because that's the main chemical that causes the psychoactive effect. You've probably heard of this cannabidiol, that's another component, and then there's a whole other list of these cannabinoid chemicals, and we're not as familiar with these other ones, but research is ongoing. Now, THC has the effect that it does because it crosses the blood-brain barrier, so it gets into the brain. And we know that it crosses the placenta. So, women who might be using during pregnancy are absolutely exposing the fetus to THC. So THC is highly absorbed in the fat tissue in the body and in the brain. And so the more somebody uses, the more and more it builds up in the fat of the body, resulting in a long elimination time. So this is, and it could be days to weeks, depending on how much somebody's been using. And this is why it's so hard to test for impairment when somebody's driving, because they may not have necessarily used just before driving, but if they had a test to see if they had THC in their system or the metabolite of THC, they would absolutely be showing that from just having absorbed it for so long. And then THC acts on the body's cannabinoid receptors, which are present in both the central nervous system, the brain and the spine, as well as the peripheral nervous system. Okay, so here is a picture of all different parts of the brain that have these THC binding sites. So all these little pink dots show where there's a high concentration of these receptors that bind THC. Why the heck do we have cannabinoid receptors in our brain? And we found these actually when scientists were trying to figure out why marijuana affected our brains. And that's how they ended up calling them cannabinoid receptors. Kind of like opioid receptors in our brain got labeled because scientists were trying to find out how opioids affected our brain. Okay, so it turns out that THC has a somewhat similar chemical structure to chemicals in our own brain called endocannabinoids. So our brain, has these chemicals that bind to those receptors. Just like, with opioid receptors, we have endorphins that bind to those receptors. So we have endocannabinoids that bind to those receptors. Okay, I want to tell you about the brain's endocannabinoid system. This is information that is relatively new. I would say the first study that came out about the brain's endocannabinoid system was in the early 90s. So this is pretty new science. How many of you are familiar with the endocannabinoid system? A little bit? Yeah? Okay. So in order to tell you about the endocannabinoid system, I need to give you a very brief primer about neurotransmission, how neurons communicate. So as I mentioned, there's the cell body and there's the electrical signal going down the axon, which then passes the message down to the next neuron. And then if you blow up this sort of connecting area called the synapse, this is kind of what it looks like. There's a space between. And so what happens is that electrical signal comes from this sending neuron that causes the release of what we call the neurotransmitters that actually travels across and docks on the little receptor sites on the receiving neuron. So that's how neurons communicate, and that causes the next signal to go on, kind of like dominoes. Okay, so how the endocannabinoid system in the brain works. So here's the sending neuron, here's the receiving neuron. So here's the electrical signal coming down. And sometimes that electrical signal gets too strong for whatever the reason. Now, the receiving neuron actually has the ability to give feedback to the sending neuron using endocannabinoids. So these endocannabinoid chemicals are made on demand, and they're sent backwards to bind onto the cannabinoid receptors on the sending neuron, and that helps the sending neuron to calm down. So this endocannabinoid system that includes our endocannabinoid chemicals, those cannabinoid receptors, it's like our neuron's volume control system. It helps neurons to keep their activity in balance. It helps to dial down neuron activity when it gets too strong. And because those endocannabinoid receptors are all over the brain, it regulates the levels of many different brain chemicals, those involved in pleasure, like dopamine and endorphins, those involved in mood, pain, appetite, motivation, memory, growth and reproductive hormones. So that endocannabinoid system is really quite critical for proper brain function and for our feeling kind of reasonably well. Now, a healthy brain is a finely tuned instrument. So, using the metaphor of a race car, so you don't want to do something that will overheat the engine, but you also don't want to do something that will clog up the engine. So you want that engine to be, working at a nice pace. And that's what the brain is trying to do at all times. Now, THC versus anandamide. So THC also dials down neuron activity to change neurotransmitter release. However, THC has a much stronger, longer effect than anandamide on brain cells. And because THC binds to those receptors, those endocannabinoid receptors, it interferes with our brain's endocannabinoid system. Now, if anandamide is like a surgeon's scalpel, it's produced on demand at each individual neuron as needed. THC is like a sledgehammer in terms of the diffuseness of the effect on the brain as well as the strength of the effect on the brain. Now, with repeated THC exposure, the brain, which is always trying to seek balance and come to an even keel, it scales back cannabinoid receptors, causing cannabinoid deficiency. So this is what happens with tolerance, why people need to use stronger and stronger marijuana with more and more THC as their brains get exposed repeatedly to THC. And so we lose those cannabinoid receptors. And so what happens in marijuana withdrawal, I call these symptoms of an out-of-whack brain. So the brain has lost its ability, with that endocannabinoid system, to self-regulate and kind of keep things on an even keel. So these are symptoms of a brain that can't tone itself down. So restlessness, anxiety, increased irritability, anger, aggression, difficulty falling and staying asleep, having nightmares or strange dreams, boredom, decreased appetite. So these are symptoms of an overstimulated brain. And it's ironic because a lot of people use marijuana to address anxiety, but with more and more use, you actually make the anxiety worse. Yes? Right. Because there was no tolerance and there was no withdrawal. Right. So now we're in the same category as the other drugs. Well, I mean, yes. Yes, absolutely.
Can I have you repeat the question?
Okay, sure. So the question is, this wasn't really known before that there was the narrative that marijuana was not addictive and there was no withdrawal from marijuana. But the science shows otherwise. Lots of studies have interviewed people who have been trying to get off of marijuana and found definite withdrawal symptoms. Now, I would just tweak something that you were saying, which is oh, so we now know that marijuana is like other substances, addictive substances that cause withdrawal, like, alcohol, opioids, cocaine, et cetera. There are different degrees of withdrawal and different kinds of symptoms related to withdrawal. Marijuana withdrawal is absolutely uncomfortable, and it makes it hard to quit. People, often end up, relapsing because they get so wound up and they need something to tone down. But it's not the same as, say, opioid withdrawal, because opioid withdrawal, you feel like you have the flu and you want to die. So that's kind of different, but this is definitely also very uncomfortable. Okay. Oh, by the way, so with opioid withdrawal and alcohol withdrawal, and actually withdrawal from a lot of these addictive substances once they've changed your brain, you are getting the same issue of the brain ends up being what we call excitotoxicity. It becomes too wound up, and the drug had been the thing that had been kind of keeping the brain sort of, toned down. And without that substance, the brain is now like a live wire, and people are just like, oh, in that withdrawal. So yes. Within 48 hours. Within 48 hours, yes. So there's what's going on in the endocannabinoids. So the question was, could you use like a dopamine receptor lotion? Lubricating, okay. Something that helps give more dopamine to the brain. Something, okay. So I was talking about the cannabinoid deficiency issue underlying withdrawal. There's also a dopamine deficiency underlying withdrawal. And that's because all of these addictive substances are involved in releasing dopamine and activating dopamine receptors in the reward pathway, in the reward circuit. And again, the brain scales back dopamine receptors when they're being constantly stimulated, okay? So when people are in withdrawal, those dopamine receptors, there are fewer of them, sort of they're downregulated, so people feel depressed. They're not able to feel the natural pleasures of life because they don't have as many dopamine receptors. And that exactly is where, there might be strategies to try and help people with that depression so that they can get through the withdrawal. Yeah, okay, great. Any other questions before I move on? Yes. Oh, yeah, sorry. Yeah. Right, right. It really does depend on, the individual brain. Like, it turns out we have lots of different gene variants that dictate how our brain responds, to addictive substances. But I want to remind you that the teen brain changes faster. So the teen can get addicted, faster, like within a matter of months, as opposed to years from regular use. I'm going to talk about how THC has been changing in today's marijuana, and that with greater THC potency, the marijuana becomes more addictive. Yeah. So, oh, another question. Yes. Yeah, even the emerging adult years, absolutely. Yeah. But I mean, the younger you start, the worse it is. You saw that trend, that like sort of negative correlation with the earlier age. Yeah. Yes. Yeah, that's a great question, right? Do the dopamine receptors come back? Studies are showing that yes, they do come back. And the cannabinoid receptors also come back, but it takes a while. Yeah. So and it's very uncomfortable until they do come back. I also want to mention that the brain changes, particularly in the reward circuitry, just as we talked about the reward deficiency syndrome, that we know that marijuana changes the brain in a way that causes this amotivational syndrome, the loss of motivation and drive. So, and it's because, remember, THC dials down activity in the brain. So it just kind of has us want to sit on the couch and not do anything. So the other really important thing that we found out about the endocannabinoid system is that it is already present in the fetal brain and is involved in shaping brain development. So in the fetal brain, it guides neurons to grow to the right places in the brain for correct function. And then through the course of brain development, it's involved in that neuron activity. It's like that volume control dial. Therefore, it affects pruning and brain wiring. It's also involved in myelin growth on neurons. So the endocannabinoid system is involved in all of these functions. And we know that pruning and myelination occur all the way through adolescence. So if the adolescent brain is regularly exposed to THC, it could alter development of that connectome. And we have quite a few studies now that have found white matter differences in the brains of those who start regular use in adolescence compared to those who do not. So this is data from a brain imaging study that specifically looked at the white matter tracts that connect the two hemispheres of the brain. So that's what's colored here. So this is the brain, these are brains of those who did not use marijuana. These are brains of those who were daily users. And you can see there's like a lack of white matter, or a thinner white matter here in those who are daily users compared to non-users. Now, this study was done comparing at one point in time, young people who had started using in adolescence versus not. And the problem with these studies is that you don't know whether these brain differences actually preceded the marijuana use, because you're only looking at one point in time. However, we have since had a number of longitudinal brain imaging studies that provide confirmation of this. So for example, this study found longitudinal changes in white matter microstructure after heavy cannabis use during adolescence. Here's another one, adverse effects of cannabis on adolescent brain development, a longitudinal study. So we now have more confirmation from these longitudinal studies that the white matter is being impacted. For example, in that study that I was just mentioning, they took adolescents and they actually followed them over 18 months. They did brain scans at baseline and then 18 months later. And they were looking at brain connectivity. That is, how much different parts of the brain activated together, which gives an indication of how well wired up they are. And they looked at specifically the connectivity between these two parts of the brain, the anterior cingulate cortex and the orbitofrontal cortex. So the orbitofrontal cortex is part of the prefrontal cortex, and it's really important in that sort of higher executive functioning. The anterior cingulate cortex, one of the functions of that part of the brain is the ability to detect error, the ability to see problems, okay? So this is really an important, sort of wiring up that needs to happen for us to be able to see when something is not going well and then correct, okay? Now, here's what they found in terms of that connectivity in adolescents who were not using. So the connectivity went up over that 18 months, and that's exactly what you want for a healthy brain development. You want increased connectivity. Here's what they found in those who were using marijuana. That connectivity actually went down. Because the myelin and pruning, you need those to go well to have better connectivity. Okay, so what else is affected by THC? So I want to highlight the hippocampus. So in this little area here, it's the command center for memory formation and learning. I call it the key to the SATs. So this part of the brain is really rapidly developing and very sensitive in adolescence, which is why adolescents can learn, much more quickly. Fortunately, this is one of the few parts of the brain that continue to grow new neurons throughout the life course. Much of the brain does not, but that does. So that's good news for us, right? In terms of our brains. Now, in terms of how THC affects the hippocampus. So remember, THC dials down the activity of neurons? Well, THC suppresses the activity of cells in the hippocampus below the level needed to trigger memory formation. So in order for us to make a memory, cells in our hippocampus have to get stimulated, activated, to then sort of send out connections which embed the memory in our brains, okay? Now, THC keeps those hippocampal cells dampened down, which is what underlies that very common side effect of marijuana use, which is short-term memory loss. You can't form memories. So that's what happens with THC. Now, with chronic THC exposure, especially in adolescence, neuron connections that are involved in memory are gradually lost or pruned away due to continual suppression. So here is a brain imaging study that looked at the size of the hippocampus among young adults who started using marijuana in adolescence. So this is the hippocampus on the left side of the brain, and on the right side of the brain, those in green are those who are marijuana users. Those in red are those who are non-users. And you can see that the hippocampus is, on average, smaller in those who were regular marijuana users through adolescence. So, I would say that there's less real estate in the brain, in that part of the brain, to learn, which is what we're so concerned about during adolescence, because there's opportunity costs. That is the time when young people are supposed to learn, and if they're not learning at that time, it's hard to go back. Now, in terms of how the brain might function with respect to marijuana, so this study was really unique and important. It's one of those long-term studies. So this was conducted in New Zealand. They had 1,000 participants that they had actually recruited at birth, but at age 13, they did a pretty comprehensive IQ test, and they started measuring substance use. And the vast majority of young people at that age had not started using marijuana. Now, they also did the exact same thing, IQ tests and assessed substance use at ages 18, 21, 32, and 38. So they followed these people for 25 years, okay? And so they were able to see how IQ changed relative to marijuana use. And here's what they found. So this is the amount of IQ change and broken down by how much marijuana use was reported. This is negative IQ change. That means it went down. This is positive. So among those who had never used, there was really very little change in their IQ during those 25 years. Those who used infrequently had a little bit of decline. If those who used regularly for 1 year, 2 years, 3 years, you can see there's this dose-response relationship. So now, just to quantify this, those who had never used, their average IQ was just about 100, which is the average IQ. But there was no change for them in those 25 years. For those who had the most regular marijuana use, their IQ on average went from 100, which was the same at the age 13 as the other group, but at the age of 38, it was down to 94, which is a pretty significant drop in IQ. Okay, so I want to cover this, and then I'm going to do a break. So marijuana and psychosis. So how many of you have seen this report from the National Academies of Sciences, Engineering, and Medicine? So this came out in 2017, the health effects of cannabis and cannabinoids, current state of evidence and recommendation for research. So what the National Academies of Sciences did was they convened a 16-member expert panel from all areas of medicine, public health, and social sciences. And they undertook a review of all the studies that have been done on cannabis since 1999. And they reviewed over 10,000 scientific papers. So this was a very comprehensive review. And they generated nearly 100 conclusions about, based on what evidence we had up till now, about cannabis and cannabinoids' effects and risks. And they categorized them as having limited evidence, moderate evidence, or strong evidence based on the research. And they found a strong evidence for a link between marijuana and psychotic disorders. This was a story on NPR in Massachusetts, where a leading psychosis expert was interviewed, and he said, to avoid risk, hold off on pot until you're 30. And more and more studies are linking marijuana and psychosis. This says adolescent initiation of cannabis use and early onset psychosis, adolescent cannabis use, baseline prodromal symptoms, and the risk of psychosis, and even a large study across multiple countries in Europe, the contribution of cannabis use to variation in the incidence of psychotic disorder. So this is a real phenomenon, that marijuana increases risk for psychosis. And why is that? Well, we have a very different plant today from what it was 20 years ago, which brings greater risks. So you've probably seen, something about this, that the THC content in the average marijuana plant has been going up and up and up. And while this says in 2014 that it was on average about 12%, that's actually low now. So Colorado's, just what you find in the dispensaries, it's much higher. It can be as high as 35%. Whereas back in the 60s, 70s, it was probably 2 to 3%. So we're really talking about a different plant. The other thing that's really crazy is that there's a growing popularity of these butane hash oil products, which are essentially using butane gas and other kinds of chemicals to extract the THC and just concentrate that. And so there are all these different forms of that: shatter, dabs, butter, etc. vaping THC oil. And these forms of butane hash oil can contain up to 90% THC. And these are, sold in marijuana stores. And as THC increases, we see more negative effects. We see more paranoia, anxiety and panic attacks, hallucinations, erratic mood swings, aggressive behavior, and something called hyperemesis syndrome. So hyperemesis syndrome is something that we're seeing more and more of. It's where, kind of in contradiction to what we think about, with medical use of marijuana for nausea, cannabis hyperemesis syndrome is when people develop persistent nausea and vomiting and have abdominal pain, diarrhea. And here's the key kind of distinguishing factor of cannabis hyperemesis syndrome. They get relief only when they're taking a hot shower or bath. So if somebody is experiencing this vomiting or nausea, often they don't connect it to their marijuana, but doctors are realizing that if they say, oh yeah, I feel better when I'm taking a hot shower, that's what's going on. Now, that cannabis hyperemesis syndrome does go away if you stop using the marijuana. And that's another big indicator of this particular syndrome. It goes away when you stop using. Okay, I'm gonna now take a break because we're gonna go on to some other health issues related to marijuana. So yeah, please get up and stretch, go to the bathroom, and let's say, be back in about 10 minutes. Great, thank you. Okay, let's gather to get started again.
If we can have people take their seats, we're going to resume. If we can have people take their seats so we can keep going, please.
Yeah. Great, thank you so much. So I just have a little bit more around what we know about the health risks of marijuana now, just in the same vein of addressing whether marijuana is harmless. I wanted to, just make sure that you had the full information of what we know based on the science around, the potential risks of marijuana use. So we have been seeing more and more studies, case studies and other studies of how marijuana affects our cardiovascular health, our heart, our arteries, blood vessels. And it turns out that marijuana use, so there's cannabinoid receptors actually, in the blood vessels, arteries, and heart muscle. And that we are seeing both acute and long-term cardiovascular risks of marijuana use. And this is among young people, okay? This is not among old people. These are among young adults. We're seeing, so we know that regular marijuana use, just any marijuana use, acutely can increase heart rate, okay? Increases heart rate. It increases blood pressure because those cannabinoid receptors are, being affected in the arteries and veins. It can cause arrhythmia, so irregular heart rate. And we have seen heart attacks solely due to marijuana. We have also seen studies that have shown there's an increased risk of death after a heart attack. Cardiac arrest, we've actually seen adolescents coming into our emergency room at Boston Children's Hospital in either a heart attack or cardiac arrest. And we find out that they have THC in their system, after they come out of their their lives are saved, they talk about their use of cannabis just before this happened. As well, it increases the risk of stroke. So it turns out that THC, it reduces the flexibility of blood vessels, which is why you get the, the potential for stroke as well as heart attack. So this is definitely something to be aware of, and what we're seeing in our emergency room more and more. So as I mentioned, those of us in states where there's, legalized marijuana, we've been seeing this effect happening in terms of emergency room visits caused by marijuana. This is actually a little old in terms of national data. This is, reports from emergency rooms around the country of visits related to marijuana use only. And this is what Colorado's been experiencing. And this is hospitalization rates related to marijuana. So we've got commercialization having happened here in 2009. Legalization of the recreational use here. And this is where they are, with their latest data. So that's been going up and up there. And, in Massachusetts, we're definitely seeing the same thing. Now, I want to particularly talk about edibles. So there's just been this incredible proliferation of marijuana edible products. And this New York Times article said, edibles induced a disproportionate number of pot-related medical crises, and analysis of emergency room admissions in Colorado found. And this is the data that they're referring to. This is the number of emergency room visits related to edible marijuana and inhaled marijuana at emergency rooms in Colorado. So the edible marijuana is really even more risky in terms of health. And why is that? So it turns out that, the time course of how marijuana affects a person very much varies by ingestion method. So, as you might, be familiar with, so if you're smoking it, it's a very quick effect because it goes into the lungs and then straight to the brain. This is the time course of if it's injected into the blood system, the bloodstream, and so that's also very quick. So within the first 20 minutes, you get the high. Here's what happens with oral ingestion of marijuana. First of all, it can take up to 3 hours to have the full-on effect because it has to go through the entire digestive system, before it kind of goes out into the rest of the body and the brain. So this is where a lot of people get into trouble, where they don't think that they took enough marijuana, particularly, the edible, and so they keep eating, more edibles. And so this is the kind of thing that happens. So 5 middle school students hospitalized after eating THC-laced candies during gym. So there's just more and more of these kinds of news stories, and certainly we see this at Boston Children's in terms of our emergency room admissions. Now, there's been the kind of narrative among proponents of marijuana legalization that marijuana never killed anybody. It's safer than alcohol, it's safer than opioids, and never killed anybody. This is the first death in Colorado after 4/20, April 20th, the legalization of recreational marijuana there. This was a college student, a 19-year-old who was visiting Colorado on spring break. He and his buddies went, straight to a retail store that had just opened. They bought marijuana cookies. He was inexperienced. And so the serving size of that cookie was 1/6 of the cookie. So So I don't know about you, but I have never eaten just 1/6 of a cookie. So he ate the 1/6, right? Nothing happened. He ate the whole cookie. He overdosed on the THC, went psychotic, and he jumped out of the 4th floor window of his hotel room to his death. So this happened, within a couple of months of legalized recreational marijuana. I would also contend that in this country, more marijuana with the gun culture we have here is a lethal combination. So this young man, who also was visiting Colorado on vacation with his family for a ski vacation, a 23-year-old, he had 5 marijuana candies, had a gun with him, and fatally shot himself to death. So it's not true that marijuana never killed anybody. It doesn't kill people in the same way that, say, opioid overdose does, but it absolutely has resulted in deaths. Now, obviously, not everybody goes psychotic after using marijuana. And it turns out that there are a number of genes that scientists are finding that increase the risk for psychosis. So this is just one of them, the AKT1 gene. So if you happen to have this particular variant, 2 copies CC of this AKT1 gene, and you're a regular user, it increases your odds of developing psychosis 7 times compared to no use. And this is just one of those gene variants that have been found to increase risk. So, we're not there yet as a society where we, do DNA tests to find out whether we have these particular gene variants. So we don't know if we happen to, have that particular risk. If your family has anybody who's, had mental illness or, a psychotic disorder, you really have to take that seriously because that puts you at much greater risk for this problem. And as parents, it's really important to divulge this kind of information to your children so that they know that, potentially there is this family history that could put them at greater risk for this. Okay, other health risks. So there are a small number of studies that have looked at the effect on the reproductive system. So remember, it's THC and endocannabinoid system is involved in parts of the brain involved in reproduction and growth. And studies have shown that among males, marijuana use is associated with a dose-related decrease in testosterone level, potential breast growth, testicular tumors, and erectile dysfunction. So those are effects on males. Now, we haven't seen very clear effects on females. There is some evidence that it might impact fertility, but it's really not well documented. So it seems that there's these kinds of effects that have been seen among males. And then, given that it does, the endocannabinoid system is involved in, the reproductive organs, there is the potential for epigenetic changes to the sperm that could impact future generations. So this study actually found that exposure to cannabis in men alters the genetic profile of sperm. So remember, sperm, unlike women who are born with their eggs, sperm are generated continuously throughout life. And so you can have, with marijuana exposure, an impact on the sperm that are generated through the life course. Now, other things that teens have said, well, isn't marijuana safe because it's used as medicine? Well, so marijuana is still largely smoked. There is an increase in vaping of THC oil, but it's still largely smoked. And no doctor would ever recommend smoking a medicine. It's like telling people to smoke opium for pain. Okay, that, it's not something that we do anymore because we have, these standardized pharmaceuticals for pain management. And, it's interesting. I hear from young people all the time, oh, I would never smoke cigarettes. I know that kills them, that would kill me. But they're daily marijuana users. So somehow they've got it in their mind that marijuana smoking and tobacco smoking are two different things. But in this study where they directly compared smoke from tobacco cigarettes with smoke from marijuana joints using machine smoking conditions, and they did like a chemical analysis, they found that marijuana smoke contained most of the same cancer-causing chemicals and as much tar as tobacco smoke, because, and especially that tar comes from burning organic matter. So whether you're burning tobacco leaves or marijuana leaves, you're still burning those leaves, and that generates as much tar. Now, there are some differences in how people use tobacco cigarettes versus marijuana. Marijuana joints are usually unfiltered, unlike tobacco cigarettes, which have the little filter at the end. Marijuana smoke is usually held in the lungs longer. However, marijuana smoking is usually not as frequent as tobacco smoking. So when people get addicted to tobacco cigarettes, you probably see them, having to use a cigarette like constantly, every few hours. That's not necessarily how marijuana is used, although certainly among daily users that could happen. So there are some differences there. But studies are showing that regular marijuana smokers do report more cough, bronchitis, wheezing, shortness of breath, and more days sick than non-marijuana smokers, even after controlling for tobacco use, if they're also using tobacco. This was from a large population study. And so they're definitely, the kinds of things that you might find from, regular exposure to tar and smoke. Okay, what is the evidence for medical marijuana? So this is, I think, really important, especially for states that are, still considering passing legislation that legalizes medical marijuana. One of the arguments that people use to say we gotta legalize the plant, they say because it takes too long to come out with pharmaceuticals, people need it right away, people are suffering. Well, there are some FDA-approved cannabinoid pharmaceuticals, dronabinol, which is synthetic THC, and nabilone, which is a chemical that also binds to the cannabinoid receptors. So there are some approved, cannabinoids. These are, used for nausea and vomiting associated with cancer chemotherapy, for, for dealing with weight loss in patients with AIDS. So what is the evidence for medicinal use of marijuana? So this is back to that National Academy of Sciences report. So there is substantial evidence for effectiveness of medicinal use of marijuana for reducing pain in adults, for reducing nausea related to chemotherapy, reducing spasticity associated with multiple sclerosis, and there's moderate evidence for helping with sleep disorders. Now, most of these studies actually used dronabinol, the pharmaceutical, cannabinoid. Now, there's limited or no evidence in the research for the use of marijuana for appetite and weight gain in HIV/AIDS, for Tourette's, for anxiety, depression, PTSD, cancer, irritable bowel syndrome, other neurodegenerative disorders, and even epilepsy, although with epilepsy there's evidence emerging for cannabidiol oil. But these are all things that people are using marijuana for on a regular basis, but there's actually not that much research evidence supporting effectiveness for these things. Now, in 2017, this paper came out in Pediatrics that tried to do a review of the research around use of medical cannabis in children and adolescents, so specifically in pediatrics. They reviewed English language studies published from 1948 to 2017 that had a child adolescent patient sample. The most commonly studied disorders for marijuana, applying marijuana: seizures, 11 studies, chemotherapy-induced nausea, vomiting, spasticity, tics, PTSD, and neuropathic pain. By the way, so for seizures, it does make sense that this could be useful. So remember, THC and CBD, the cannabinoids, dial down activity in the brain. And seizures come from like an electrical storm happening in a part of the brain where that neurons get too active. Now, so that research review, what they concluded was that there is good quality evidence for treating nausea among children undergoing chemotherapy, and that was using dronabinol or nabilone. But they had many had the adverse effects: drowsiness, dizziness, and hallucinations, because the THC can cause hallucinations. They found moderate quality evidence for use in treatment-resistant epilepsy. Most of these studies tested the CBD-only oil, so no THC, and found good effects, but they also found a lot of adverse events: diarrhea, vomiting, fatigue, drowsiness, elevated body temperature, and abnormal liver function. So there's been a lot about how CBD is like the wonder drug, for just about everything. But it is important to understand that, I don't think there's ever a free lunch. And so it's important to, have some, good research to really understand how this works. And that was definitely a concern. So the bottom line, in terms of medical marijuana for pediatric conditions, currently there are very few studies on efficacy, safety, or tolerability of marijuana for pediatric conditions, while we have a ton of research showing risks to the developing brain. So that's where we are right now. But there is a lot of research happening, so maybe we'll progress from here. Other things that teens say: well, my parents smoked pot when they were growing up, and they're fine. Also, marijuana is safer than alcohol. So here's some useful responses. Today's pot is so different from the pot that was used, back in the 60s and 70s. It is much more potent, we talked about that, and therefore, comes with more risks. And we know so much more today about marijuana's risks for the teen brain. We know so much more about the teen brain, and we know so much more about how marijuana affects the teen brain. And we have lots of other examples where knowledge has changed our attitudes and behaviors. For example, tobacco. Back in the 50s, 60s, like everybody smoked, and now very few people smoke. Trans fats. So I grew up eating Twinkies. I stopped eating Twinkies once I found out about the trans fats, right? Twinkies actually, the company that makes Twinkies, they came out with a non-trans fat version, right? We know about concussions, so now everybody's wearing helmets. So we learn all the time, and hopefully we are sort of changing as we go based on that knowledge. Now, there have been a number of studies that have actually asked teens, why do you not use marijuana? So here are the reasons that they gave. Don't want to get addicted. that teens who feel that any marijuana use could be harmful are much more likely to, avoid marijuana. It's against my beliefs. They don't like being around marijuana users. And they are, primarily in peer groups where the whole peer group really doesn't use. So these are useful, I think, in terms of prevention strategies in how to promote or prevent use. Now, so this, my parents disapprove of it. So let me show you the data that is from. So this is, again, from the National Monitoring the Future survey data, where they asked 12th graders who weren't using marijuana, what were the top reasons for abstaining? And this is from 1996 to 2012. And as we saw, the perceived risk of harm becomes less and less of a reason for avoiding. They just, they're being influenced by the general culture. And so concern about the risk of physical harm, of psychological harm, those are going down. But, I'm a parent of teens and young adults. This is one of my favorite graphs. This is showing that, teens consistently are choosing not to use because their parents disapprove of it and have communicated that to them. So it's really important to educate and equip parents with the science that we just talked about and strategies for talking to their children in an effective way about this. So, really having parents get educated so that they can start the conversations young, as early as possible, and to continue them in an age-appropriate way through the life course. Because teens are less likely to use drugs when parents talk about drugs and set clear rules and consequences. So these studies looked at the rate of using alcohol or drugs among those, by whether teens said that their parents talked to them about drugs, set clear rules and clear consequences of drug use. So this is the percentage reporting use of alcohol or drugs if they never talked to their parents about drugs. This is among those who reported talking a lot to their parents about drugs, having communication. So you can see those who report parents never setting clear rules, never setting consequences, have a much greater rate of using compared to those with parents who make those clear. And this is a great resource for parents. It's the Time to Talk Kit. And I love it because it really gives specific ways of how to say things, how to find those teachable moments, how to teach kids about drugs, how to respond to the question, did you do drugs? So this is available for free at the drugfree.org website. Now, another promising strategy. So this is a study that did something really interesting. They were looking at how to promote healthier food choices among teens. And what they did was they took advantage of the naturally rebellious nature of adolescence. So here it says, the inner rebel employed to shun junk food. So what they did was, it was basically media literacy training. They showed adolescents and taught them about the kind of deceptive, predatory marketing strategies used by fast food companies to sell junk food. And what they then did was they looked to see what kinds of food choices those kids made in the cafeteria afterwards, after receiving this curriculum. And they found that, particularly among boys, that there was a significant change in the food choices that they made after they learned about this, about their being targeted in that way. So I think this could be used, around sort of revealing the predatory practices of, this was effective in revealing the predatory marketing practices of big tobacco. And so, we're seeing that the commercial marijuana industry are using the same strategies that the big tobacco industries had used previously. For example, marketing tobacco to youth. So you probably remember the Joe Camel, marketing campaign, really to make it like kind of friendly to young people. Well, and also tobacco companies made these kinds of products, candy cigarettes, to get, kids used to, cigarettes. Well, here's marketing marijuana. These products are all available in, and have been for a long time, actually, in the commercial marijuana industry. This is particularly egregious here. This is like almost like a pacifier. It's a ring pop, but it's a ring pot. So these products, specifically use images and branding that kids are already familiar with to make it, seem kind of friendly and delicious. So if, like young people, if they can see that they're being targeted, potentially may get angry about it and choose to not, feed into this. Also, today, young people are very conscious of the environment, I find. That there's, a lot of activism around, environmental preservation. And the US marijuana industry is generating a lot of toxic waste and using a lot of resources. This article, Toxic Waste from US Pot Farms Alarms Experts. These are discarded butane gas cans from all the butane that's used to do the extraction to create the, THC oil that goes into edibles as well as into the vaping oils. So, just to show about how this is impacting our environment. And, we do see that when we activate teens, they fight back. So here's a high school in California where, some students just got fed up with all the vaping. And, vaping could be either the nicotine or the THC oil. They created these T-shirts and said, look, we're going to come out and say athletes don't vape. They organized a whole event. They started a movement at their school to, make more socially normative that vaping is not something that everybody does. So again, this could be an important strategy. So in terms of take-home points based on the latest science, so we now know that adolescence and young adulthood is a time of sensitive brain development. The teen brain can get addicted more quickly because of its neuroplasticity. Repeated exposure to marijuana can have lasting effects on brain structure and function, for example, memory and IQ. Today's marijuana is a lot more potent, so it's more addictive and carries more risks to physical and mental health. And the risk of psychosis is greater, especially for those with family risk. And marijuana use has been shown to cause heart attacks, lung problems, testicular cancer, reduced testosterone, and severe vomiting. So in this era of, basically legal marijuana, alcohol is legal for adults, tobacco is legal for adults. I advise delaying use as long as possible, just to give your brain time to fully mature. Just as, I think young people would not want to engage in something that might impact their growing to their full physical height. So my son is an athlete, and he's 5'8", but he always says he's 5'9 and a half. So just as they would want to grow to their full physical height, let's teach them about their brain so that they know how to give their brain the best chance that it has to grow to be the best brain that they can have. So the future promise of any nation can be directly measured by the present prospects of its youth. This quote from John F. Kennedy really is why I went into adolescent health in the first place, because adolescents are our future. They are our nation's greatest natural resource. And so, that's why I feel so strongly about working towards, helping youth thrive to be the best them that they can be. And they are really important in terms of, advocating for change, and a big part of, our future in terms of addressing the challenges of our society. So, giving young people that orientation that they are really important and that their brains are really important. So, with that note, I'm going to say thank you for your attention, and I'll take questions. So, any questions? Yes? Yeah. Right. So the legislature didn't actually legalize marijuana. It was the population. So in Massachusetts, it was by ballot vote, as it was in Colorado and California and other places. The legislature, a group of them had gone out to California and Washington State to kind of, see what other states have been experiencing, and they came back and said, we don't want this here. But it was the population that was, I think, swayed by a lot of marketing, false marketing, actually. So anyway, but we did actually, so there's a group of us that are working sort of at a grassroots level to kind of inform the development of regulations in this new era. One of the things that we're working with legislators on is trying to get legislation passed that limits the THC potency in products that are sold. So, why do we need 90% THC products? Given that we know how much that can, trigger psychosis and have all these other effects. We also are working towards, and I don't know that this is going to fly at all, but working towards changing the age to 25, yeah. But these are things that, we are bringing to legislators with the science, saying, okay, this is legal now, but let's try and do this in a smart way to reduce the potential harms. Yeah. Any other questions? Yes.
So we know what the research says about marijuana, and we're a small community, so obviously it starts with parents.
Mm-hmm.
But as school and community, what are the other things we can do? I'm thinking about the social emotional learning. We've tried DARE, we've tried the Just
Right.
So what advice do you give us as a community?
So what advice do I give communities around prevention, not just of marijuana, but really all addictive substances? Definitely, the National Institute on Drug Abuse has a report that summarizes sort of the best programs that are focused on the early childhood. And so that's a good resource. Because, a lot of the reasons that young people end up, getting involved with substances and then getting really hooked on substances is for emotional coping, stress coping. And whether that's from just, the stressors of life is stressful, and they don't have necessarily, developed social and emotional good coping skills yet. So they, find that the easy way to address it is to go to the substance. So that, and there's also, of course, childhood trauma. That is pretty widespread. So those are typically things that we found that are key risk factors for developing addiction. So if you can get in there early enough to teach them those healthier coping skills and how to address the stressors of life, because life is stressful at any age, that could go a long way, I think, into having them not immediately reach for something that will narc out the stress. Exercise, being engaged meaningfully in something that they're passionate about, having a sense of purpose and meaning in life, those are all things that have been found to be protective. Forgiveness, being able to let go of slights, because that's, anger is hard to bear. So forgiveness, being able to forgive has been found to be a protective factor. Any other? Does that answer your question? Yeah. So in terms of community program, so I really strongly believe in the community coalition model. So it really does take a village to raise a child, and so a whole village really needs to work together to provide that wraparound environment for young people, so that they both feel that they have a climate in which they feel well held, in the environment, but also that, works at multiple levels, like in terms of availability of substances. That is a major, access is a major risk factor. So dealing with access, dealing with, what happens in the schools. I think suspending kids is really counterproductive. That, often then they just sit at home, and what will they do? Probably use substances. And so we've been moving towards, in Massachusetts, trying to support schools in having kids do maybe in-school suspensions, but that, there's kind of first degree, second degree sort of, responses in terms of, having to complete an education program around, substance use, having to, maybe do some kind of social emotional learning, more intensive program. So those are the kinds of things that are available through the school system. And then in the community, again, having things that kids can meaningfully engage with. So whether it's sports or chess club or whatever that they can do rather than be bored, and then looking for other ways to find something interesting to do. Yeah. All right, so there was, yes. Oh, sorry. Oh, yeah, right.
I was wondering if you have any statistics on the percentage of kids who use in relation to their parents using?
Right.
Since you talked about how important parental involvement is
Yeah.
in the education?
Well, so I don't have specific statistics, but I can tell you that the studies are very consistent that parents' use of substances is a big influence and risk factor for young people using, for their children using. Yeah. So that is really concerning as we're seeing adult use of marijuana ramping up. Not just in terms of their modeling, but also leaving the product around their house where it's, accessible. So, yes.
Could you speak a little bit to the CBD oil craze as it
Yeah.
pops up in our community?
yeah.
It's, it's clear the message is it's safe, it helps you sleep, there's no issues. And is there any brain research that speaks directly to just the CBD oil use, or is that the new candy cigarettes of our era?
Right. Yeah, thanks for asking that question. It's really a good question. So, so CBD has been researched and found to have in the laboratory certain properties like, it's antipsychotic, anti-inflammatory, anti-inflammation. Now, that's been primarily done on animal studies. Now, the CBD can be taken in different ways, and we really don't think it's a good idea to be ingesting CBD unless there's, because of that liver toxicity potentially. Now, there's been just this huge proliferation of CBD oils, that you put, or lotions or ointments. I don't think that that's really as dangerous. It's just on the skin. I hear varying reports of efficacy. So one of the things is it's really a wild, wild west right now in terms of regulating this industry. So people can slap on their product that it's CBD, but unless you test it, and testing has shown that the content of these products can be wildly different from their labeling. So we don't really know how much CBD is actually in these things. So you got to kind of take everything with a grain of salt. In terms of the research evidence, there isn't that much, in terms of the gold standard of research, like double-blind placebo-controlled trials, because the placebo effect is real, right? When we think we're doing something that's helpful, it can go a long way in having us feel like it's helping. But that's why you need these placebo-controlled trials. They don't exist. Yeah. So it's really just a free-for-all right now. Yeah.
Okay, so I had a question. Today we focused primarily on youth, talking about youth and the brain development and things like that. But the same health risks and change in IQ and things like that would happen even after 25 years old. So even if you started at the age of 30, 35, 40, you're still going to be at increased risk for heart attack, stroke, all that kind of stuff, because it's still changing the arthrosis of the arteries, things like that, right?
Right.
Yeah. So
Absolutely.
really the takeaway too is, even though it's legal at the age of 25, potentially at some point in some of these states, it's still not a good idea to start at any point in time.
Right. So those cardiovascular risks, those are acute as well as chronic, from chronic use. And that's been shown for, any age. I was just showing that those absolutely affect young people too, because, young people tend to have very physically healthy bodies. So the fact that we're seeing those in emergency rooms in a pediatric hospital is saying something. When you're older, you already have an elevated risk for these cardiovascular problems, right? So to have that added to it is even worse. The other thing that I worry about is, given the high THC content, and THC is what really is the psychoactive chemical and stimulates the reward pathway. We are seeing that Parkinson's disease can get triggered by addiction, like chronic exposure to addictive substances, because Parkinson's disease is where your dopamine neurons start to malfunction in a part of the brain called the substantia nigra. So if your substance use, continually stimulates those neurons, that can cause problems in that part of the brain. So these are the kinds of things that we're seeing in later adulthood developing from long-term marijuana use. Yeah.
I have two questions. So, kind of on the line that you were talking about, if chronic users, when you start in your adolescence, as they get older, will they develop Alzheimer's disease maybe at a younger age?
So we worry that they're going to have decreased IQ at a younger age. And there's so much that goes into Alzheimer's and dementia that, yeah, that's possible. I mean, I don't know that the studies are there yet.
Right.
There are more studies actually on how alcohol use can increase the risk for dementia. Alcohol also is a depressant for the brain. And the brain, as I said, is constantly responding to exposures, even in the adult brain, but less, kind of changing quickly. But long-term exposure to alcohol can increase risk for dementia.
Okay. And then the other question I had was with the genetic risk that you were
Yes.
talking about and mental health issues, could you expound on that a little bit more?
Right. Well, so regarding like schizophrenia, for example, what we are seeing is that those with genetic risks, like those particular kinds of gene variants that we found to be associated with a greater risk for schizophrenia, those individuals may have developed schizophrenia anyway, but what the regular marijuana use is doing is it's lowering the age at which it starts. So it's creating earlier onset of the symptoms and of the development of the disorder. Yeah. But we also see that psychosis can happen even among people who have no family history because of that high THC content. So, yeah, both are happening.
Thank you.
Okay, great. Thank you. So as someone who's fighting this great battle against vaping right now, a lot of questions that we're getting from educators and parents is vaping CBD as a young person. Do you have any insight on the messaging that we should be using around that? And then I have a second question too, but you can answer that one.
Wow. So why are young people vaping CBD? I'm curious. Do you have a...
The perception that it helps with stress and depression, anxiety, just the messaging that we've heard with all things CBD.
I see. Right. Well, I mean, I can't say that, vaping CBD is as dangerous as vaping THC. But that's where, we don't have very much research on the long-term effects of regular CBD exposure. We're just we're in a new era here. And that's why I wanted to highlight the abnormal liver function because the liver can, be like if you damage your liver, that's a one-way street. You need a liver transplant if you're going to damage your liver, ultimately. So, we just don't know enough, and I kind of feel like then it's a Russian roulette that we're doing right now as a society around, CBD.
Yeah, a lot of the messaging that I've been putting out there is that it is unregulated.
Yeah.
And especially if you're vaping something, you don't have the realization of how much you're consuming either. So that's also what I've been informing them, but it's good to know about the liver function too.
The other thing, though, is to not be so trusting that the labeling on these products is correct, because the information coming out from these testing facilities in states where it's legal, they're finding that, like Washington State, when they started their testing, they found 40% of the samples that they tested were wrongly labeled. Like, that said that they had high CBD, but that, and not as much THC, but actually there was a lot of THC. Because CBD has become so profitable that there's a lot of pressure to label things as CBD. Yeah.
And then just my second question, with the designation of a Schedule I drug, does that influence the way we can research CBD,
Yeah.
THC,
marijuana?
That's a good question. So I would say not now, in that there's a lot of research actually happening in laboratories that I know of with like the specific compounds in the plant. Harvard and MIT actually just got $9 billion donated to do research on marijuana from a private investor. And so there is research happening. Now, I personally think marijuana should be rescheduled as a Schedule II. So, I don't know where things are going to go, but that's my personal opinion. Yeah.
So it can't be federally researched, right?
No. People, so people do get marijuana. If you're getting federal money to do research in marijuana, you have to get your marijuana from sanctioned providers. Those providers of the plant that are kind of officially allowed to provide it. And there are a few places in the country that do that. Yeah.
And kind of to piggyback on what she was saying about
Yeah.
research, just more on the potency level of
Yes.
research. I had heard at some point, I don't know, a few months ago, a colleague had mentioned that the government had been researching on like a 12% maximum potency or something that was a lot lower than what we're seeing for the potency that's out there. Is that true? Do you know what potency level is being researched? Is there someone researching that
No, it's true.
90%?
It is true. Those official grow sites do not have the kind of the marijuana that's out in the commercial sector. And so that is absolutely true. What we're seeing in the commercial sector is, 35%, as kind of a max, whereas in the official labs, they're probably growing no more than 15 to 18%. So that's a problem. But I know my colleagues at Harvard, a number of them are doing studies of, individuals just accessing products through the commercial sector and asking, what's the potency that they're using on a regular basis, and having them bring in product so that they can test it. Yeah.
So I had a question that came to me. With all the talk about prevention, what is the
Yes.
first step when somebody has already been using, getting, to quit, essentially? What would
Right.
you recommend as that first step?
So, there's no medication for marijuana dependence, for treating marijuana dependence, unlike with opioid dependence or even alcohol dependence. So that's one of the difficulties. And what we're seeing anecdotally in our treatment program at Boston Children's Hospital, we're seeing young people coming in with more withdrawal symptoms than we'd seen before. And that's, I'm sure, because of the more potent THC content in the products that they've been using. And so what we end up doing is, and this is just for those who are, really kind of heavy users, they're in like a medical psychiatric model of care where they may need antidepressants for a short while or anti-anxiety medications for a short while to get them through that really tough period of withdrawal. So there's that piece. And then for those who may not be like quite there in terms of severity of use, what we found effective is motivational enhancement therapy or motivational interviewing in conjunction with cognitive behavioral therapy. So this is to help young people learn to cope with stress and anxiety in different ways from just reaching for the marijuana. So this is, therapy, like learning behavioral skills. Also, what's been found effective is contingency management. So contingency management is essentially paying young people or people in treatment to stay clean or stay having negative drug tests. And that's been found to, because it's behavioral reinforcement, that's been found to be an effective addition to that, cognitive behavioral therapy, to give that extra motivation to not use. Yeah.
Is there any research on marijuana and ADHD and like marijuana counteracting with ADHD medication and those
Right.
sorts of things?
Counteracting with ADHD.
The first part is like
Right.
marijuana
Well,
and ADHD.
so there's absolutely research that shows that kids with ADHD are at greater risk for using marijuana and developing marijuana addiction. And when you think about it, kids with ADHD, their brains are, they probably feel more hyper and more overstimulated, and that that THC kind of calms them down in the short term. But the ADHD already has difficulty with focus and attention and memory, like working memory. So the THC is not good for those things. That will just, it's like, again, it's counterproductive. So in the short term, they get relief, but in the long term, it makes their ADHD worse. So this is the challenge of ADHD. Yeah.
I was just trying to see if someone had already asked while I was in the restroom, but I was wondering about, interestingly enough, when you going through the slides with you, in terms of CBD and anxiety, is it a misconception that it's supposed to help anxiety? And then the list of things that we're not sure if it actually helps with. Right. So some of the arguments we get as prevention people is that CBD is helping the anxiety, and so therefore they automatically assume the THC is helping the anxiety, which when I hear from anecdotally is actually the opposite, that THC kind of increases the anxiety.
Well,
so
right, but remember, it's the acute effect of THC or CBD really is to dampen things down. And so there is that sort of short-term getting a relief from, anxiety or depression or whatever. But the problem is the brain changes, develops tolerance, right? And so over the longer term, when you're not using, you feel more anxious and more depressed. So then you have to keep using and use more because of the tolerance. So it just becomes this vicious cycle. Yeah.
So we talked a lot about teen years and then young adulthood. There's that trend of more pregnant women smoking marijuana.
Yes.
Is there any research on the impacts on the fetus and then through that childhood development?
Yeah. So there's not that much research, but what I have seen is that, remember, THC crosses the placenta, and the endocannabinoid system is involved in the development of the brain in the fetus. And so in like molecular, in biological studies where they have actually looked at, like they've taken, like rats where they can really control things and expose, these fetuses to THC and these fetuses to not THC, they're finding differences in the growth of the neurons in their brains. We don't have that kind of study in humans, right? But I do know that women who are, using marijuana, their babies tend to be born premature. It increases premature birth. And then in terms of how their brains develop, the babies, I have seen that there seems to be an increased risk for developing addiction later in life for babies that were exposed to THC in utero. Yeah. Any other questions? Yeah.
As I'm walking, please remember to fill out your evaluations. We really appreciate it.
Sorry.
Might as well get some steps in as I go. Hold on, we got one more question up here.
I was just wondering,
Yes.
if there's heavy usage, say in like that 18 to 25 year period,
Yeah.
and then they quit, the brain's kind of done developing then. You have a smaller hippocampus, you have a less well-developed connectome. Is that, even though the brain will adapt some, is that something that will persist then in like lower IQ and more impulsivity and stuff? I mean, is there permanent brain change?
Well, so I think I mentioned, at least with the hippocampus, the good news is the hippocampus continues to make new brain cells throughout life. And what I tell young people is the sooner you quit while your brain is still developing, the better chance you have for your brain to actually kind of recover, as opposed to when you're 50 or something, right? With the hippocampus, I think there is potential for, kind of regaining function in what you might have had before. The connectivity issue, though, is less clear. The speed of processing may never be what it could have been without the THC impacting the wiring, the pruning, the myelination. So, but we don't have the longitudinal brain imaging studies yet. There is a large national study called the ABCD study that recruited 10,000 kids starting at ages 9 and 10, and they are going to be followed for 10 years with brain scans every other year. And so that study will hopefully, give us the information about, the course of brain development and look at, for the kids who quit, what happens to their brains versus kids who don't, et cetera. Yeah. So that information is coming, but we're not totally there yet.
So is there any other questions? Okay, with that, like I said, please make sure you sign up for the weekly updates so you get the handouts, turn in your evaluations. We'll watch for a posting about the video coming out, hopefully within the next couple weeks. Thank you again, Dr. Harris. Let's give her a round of applause.
Thank you.